So the Pythagorean identity is sine squared of an angle plus cosine squared of that same angle is equal to 1. There are a couple other forms of this. Tangent squared of an angle plus 1 is equal to secant squared of that same angle. 1 plus cotangent squared of an angle is equal to cosecant squared of an angle. So where do these come from? Let's go back to right triangles. I'm going to call the hypotenuse of this triangle r. I know that the cosine of any angle is equal to the adjacent side over the hypotenuse. So in this case, I'm going to call the adjacent side A, and I'm going to call the opposite side B. So in this example, the cosine of this angle x is equal to A over r. If I solve this for the side, the leg, I get A is equal to r cosine of the angle. Okay, and I could also do that for the vertical side, the B side. Sine of the angle is equal to the opposite side over the hypotenuse. So in this particular scenario, sine of the angle is equal to B over r. So r sine of the angle is equal to B. R times the sine of the angle is equal to B. R times cosine of the angle is equal to A. A and B are the legs of my triangle. So I can plug that into the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared is equal to c squared. My c in this case is an r, the hypotenuse. My a is r cosine of the angle. And my b is the r sine of the angle. So if I simplify these, I get r squared cosine squared of the angle plus r squared sine squared of the angle is equal to r squared. Assuming r is a non-zero number, I'm going to divide everything by r so I can get rid of it. And I get cosine squared of an angle plus sine squared of that same angle is equal to 1. So that's where the Pythagorean identity comes from. Now how do I get to these two forms over here? Well, I can divide everything on the left side, everything on the right side by whatever I want. That's property of an equation. So I'm going to divide everything by the cosine squared of the angle. And if I simplify that, this right here becomes 1. This over here becomes tangent squared of x. And this over here becomes secant squared x. If I divided everything by sine squared, then I would have cosine squared x over sine squared x plus sine squared x over sine squared x is equal to 1 over sine squared x. This over here becomes cotangent squared x. Sine squared over sine squared is 1, and 1 over sine squared is cosecant squared. So this Pythagorean identity, the main one, is telling you that if you're squaring sine of an angle and cosine of an angle and you add it up, you're going to get 1. And these are just a couple different forms. There's more forms if you are messing around with identities of each trig function, but this is where the Pythagorean identity comes from.